Okay, our final topic before we go for another break is harmonics. We mentioned them briefly. So only frequencies of harmonics are allowed for standing waves. These are known as the different modes of vibration. Okay, so the frequencies allowed are an integer number, so that's just any old integer, multiple of the fundamental frequency of a given string. So this number f0 is characteristic of a certain string. It depends on what it's made out of, depends on how thick it is, and so on and so forth. Okay, so if I've got a guitar string, got fixed ends, the fundamental or first harmonic is the mode where the full length of the string is used for half a wavelength. You can see, like, if I were to extend this wave pattern, it would continue for another length. So this is 1/2 wavelength. So in other words, the wavelength here is 2L. Okay, moving up to our, and we sort of define the frequency of this mode as F0. Moving on to our next harmonic, we've got a full wavelength here equal to L. So λ1 is equal to L. The velocity of all these waves traveling on the string is the same string, same medium, so the velocity you would expect to be the same. So if the velocity is fixed, then F is just inversely proportional to the wavelength. So the wavelength is halving, therefore the frequency is doubling. Okay, let's go one further. We now have 3 halves of wavelength, which means that this wavelength is 2/3 of the length of the string. If compared to our fundamental harmonic, well, instead of halving, what have we done? We've thirded it, essentially. We've divided by 3. So if we've divided the wavelength by 3, we have multiplied the frequency by 3. Pretty neat. The frequencies just goes 1, 2 times, 3 times, 4 times, so on and so forth. Which is pretty nice. It's nicer to think about the frequencies than it is to think about the wavelengths, I humbly submit. And just to be clear, you've got antinodes there. And the most obvious nodes are always going to be the ends because they are literally physically fixed on a guitar. One end fixed to the frame of the guitar itself, the other end will be fixed to the other end of the guitar, but you can interfere with it by, fixing it with your finger. And that's how you can play with which you can alter the effective length of the string. Sweet. How much time we got? Not too much time, so I will just go through this question. The diagram below shows a taut guitar string fixed at either end. Plucking the string can form standing waves on the wire. Sketch. Is that command word? The 4th harmonic of a standing wave on the diagram and label the position of the nodes. Right. So the 4th harmonic, it's the next diagram on from these 3. So I'm expecting to have 4 half wavelengths on there, or 2 whole wavelengths. The easiest parts to start with, though, are there's definitely going to be nodes at these ends because they're literally fixed. 2 whole wavelengths need to fit on here. So in the middle, there'll be a node. And there'll also be nodes at the quarters. All that remains then is to sort of do my best to draw Do my best. You know, the amplitude is a bit screwy, but oh well. I'm sure you can do better on actual paper. It's not so easy on a graphics tablet. Yep. Does my question says label the positions of the nodes. Okay, that's fine. Node. You can write node 5 times, or you can probably, you know, save yourself a little bit of time.